Alright, this video is going to be on the characteristics of functions that we're typically going to be looking for. So first we're going to define each thing and then we're going to actually do it. So the first definition we're going to look at is transformations. And with the transformation you are taking the basic function or the parent function and you're transforming it. And transformations might be moving the graph to the left or to the right, moving it up or down, reflecting over the x-axis or y-axis, or vertically or horizontally stretching or compressing. And I went ahead and just wrote vertical because in this class that's typically all we look at, and I only wrote reflect over the x-axis because we do not often talk about reflections over the y-axis in this class. Alright, next, the vertex is a high point or a low point. We often use the vertex as our kind of reference point for how we're transforming the graph around. So even graphs that don't technically have a vertex, like a cubic graph or a rational graph, we'll still talk about like a locator point that can be found the same way as the vertex in some of the other graphs. Next is the domain, which is all possible x values for which the function is defined. And when we write out functions, we always say like y equals the equation or f of x equals the equation. So in these definitions, when I talk about the function, I'm really talking about the y value. So if you want to write that in your notes, that might make these definitions make more sense. The range is all possible y values that are a result of those x values. The increasing interval is the x values for which the function increases. So as you plug in these x values to the equation, your y values would get larger and larger and larger. And again, if you want to cross out function and put y instead. The decreasing interval is those x values for which the y values decrease. And constant intervals are the x values for which the y values stay constant. So even if my x values might be increasing, maybe my y values are continuing to be 5 or something like that. The local maximum is the largest value for the function within a certain range. So again, the largest value for the y coordinate within a certain range, and that could be for the little piece of the graph that we are drawing, this is the highest point. As opposed to, I'm considering every possible point on the graph and it's the highest. That would be the absolute maximum. So this is just saying we're looking at a picture at one specific spot, what's the highest point in that specific spot. The local minimum is the smallest value. For the function within a certain range. And then intercepts are where the curve or where the graph intercepts the axes. So we always have a Y-intercept and an X-intercept. Well, not always, I guess you could say that they're undefined, but we can always look for them. Alright, so if we look at a specific example here, this is a quadratic function. And first I'm going to go ahead and look at the transformations. And you can see them in the graph, but it's probably a little bit easier to see them in the equation. So the first transformation is this negative sign in the front. That means that the graph has been reflected over the x-axis, which is why the parabola opens down instead of opening up like normal. The next transformation is that number 3 there. That is telling you that you have a graph that is vertically stretched by 3. So that means instead of this graph increasing, going over 1 up 1, over 1 up 3, over 1 up 5, over 1 up 7, those growth numbers are going to multiply by 3. So over 1 up 3 over 1 up 1 becomes over 1 up 3. Over 1 up 3 becomes over 1 up 9. Over 1 up 5 becomes over 1 up 15. So all of those numbers multiplied by 3. These go down instead because of that negative. So you could think of multiplying those growth numbers by -3 instead. Our next transformation is that -2 in the parentheses. We're going to the right 2. And then that number on the end tells us that the graph has been shifted up 3. We want to be able to find the vertex. You can find this from the graph and from the equation. So right here, there's the vertex. It goes right 2 up 3. Or you can see it from the equation if you look at this number and this number. And it's always the opposite of what's in the parentheses. So that's where the +2 came from. And then exactly the number that you see on the end. Next, we'll go ahead and find domain and range. So if I look at the graph, I can see that the x values between 0 and 4 are definitely being used. All these x values are being used. And if I were to continue this graph with the arrow and just make it go on forever, then I can see, well, 5 is going to be used next. And then if I continue it further, 6 is going to be used and 7 is going to be used. And as I continue, I'll see that every single value on the graph from the left all the way to the right will actually work to be part of the parabola. So I'm going to say that my domain is all real numbers, or I can write that it goes from -infinity to +infinity. And you can kind of see that in the equation as well, because there's nothing in this equation that leads me to believe I shouldn't be able to plug in a number. I could plug any number in for x and subtract 2 from it and square it. There's no reason to limit that answer. For the range, I want to look at the y values that I can see. So if I look at the graph from down to up, if I look at the down part of the graph, I can see this arrow, so that tells me that all these negative numbers are going to be included in my range. And as I move my way up the graph, I can see -6, -5, -4, -3, -2. These are still part of the range. And as I go up, I can see that 3 is part of the range, but then above that, none of that is part of the graph anymore. So I'm going to say my range is from -infinity all the way up to +3. And +3 is a point on the graph. I can put my pencil on it. It's definitely included there, so I'm going to put a bracket. Next, I've got the increasing, decreasing, and constant intervals. So I want to find the x values when the y values are going up or down, or where they're staying the same. So over here, I'm going to draw a little stick figure. And I'm going to pretend that he's walking right here, so it's kind of like he's going over a mountain. Right here, he's walking uphill, so this is increasing. And then he gets to the top of the mountain, and he flips over and goes over the other side, and that's going to be decreasing. So here, if I plug these x values in, my y value is going to get bigger. If I plug these x values in, my y value is going to get smaller. So it looks like it's increasing up until you hit the vertex. The x value at the vertex is 2. So you're increasing from numbers that are negative all the way up to 0 and then up to 2. So if we're increasing, I'm going to say we're increasing from -infinity up to 2. And then after 2, we switch to decreasing. So decreasing, I'm going to go from 2 to infinity. Now here, even though 2 is a number that's on the graph, I can see where x equals 2, it's a point right there. I do not put brackets here, because if somebody asked you a question, is the graph increasing or decreasing at 2, and you covered up the rest of the graph and you only looked at 2, that's a point. And points don't slant. They don't slant up, they don't slant down, they don't slant the same, they don't do anything. So we can't say that we're including 2. We're just saying it increases up till you get to 2 and it decreases once you get past 2, and at 2 we're not really sure what happens. Now there is no point where the graph levels off, and so for constant we're going to say none. It does not level off. Alright, next we want to look at max and min. So the maximum, you can go ahead and go back and add this to your notes. A local maximum is going to look like a mountaintop. And a local minimum is going to look like a valley, like the bottom of a valley. So this picture looks like it has a mountaintop. That means it has a maximum. And the maximum is that vertex, that 0.23. For the minimum, I'm going to write none. Alright, and then last we'll go ahead and look for the X-Intercepts and the Y-Intercept. So the X-Intercept looks like it happens at 1 and at 3. And I'm going to make sure I write those like points, because X-Intercepts are points. And for the Y-Intercept, I can see that it probably happens somewhere down here. I'm just not sure exactly where. So I know that an X-Intercept is written where there's a number for the X value but a 0 for the Y value. A Y-Intercept would be the opposite of that. There would be 0 for the X value and a number for the Y value. So if I want to figure out what the Y-Intercept is, I can just plug 0 in for X. So I have Y equals -3 multiplied by 0 minus 2 squared plus 3. So that gives me -3 multiplied by -2 squared is +4. And now I've got -12 plus 3 is -9. So my Y-intercept is 0, -9.